All right, let's look at the questions from checkpoint one. Go over a possible solution for them. So question one, you're given two straight lines, and all you're really told about them to start is a pair of points that each one goes through. So part A of this, I want to find the equations of both those lines. So the way that I think is the easiest to go about this is to first find the slope, find the y-intercept, and you can put them in y equals mx plus b form. So what do we know about line P? We know it goes through 2 points. I can find the slope from those 2 points. So slope is equal to y2 minus y1 over x2 minus x1. Let's say y2 is the point on the right. So that y value is 2 minus the first y value of 1. So 2 minus 1 over 4.2 minus 0. So that gives me 1 over 4.2. So let's find an approximation for that. 1 divided by 4.2 comes out to be 0.238. And Q, actually, we're not done with P. Let me keep going. So what do we know here? We know there's going to be y equals 0.238x plus b. So typically we'd have to calculate what the y-intercept is, except I'll take a little bit of a shortcut here. We're given the y-intercept. The y-intercept happens wherever x is equal to 0. So when x is equal to 0, y is equal to 1. So in this case, I know that b is equal to 1. I don't think we get as lucky for Q, but let's go ahead and calculate it. What's the slope of line Q? We'll do it the same way. Y2 is 3, y1 is 2. And then subtract the x values. 5.1 minus 3.2 equals 1 over, I believe that's 1.9. What is 1 over 1.9? Something a little bit bigger than 1/2. Yep, 0.526. So 0.526. So I get y equals 0.526x plus b. So don't know the y-intercept this time. We're going to have to calculate b. All right, so now we need to calculate what the y-intercept is for this line. So we can use either one of the points that I gave for that. I'm going to go ahead and use the first one, the 3.22. So what is y? 2 is equal to 0.526 times x, which is 3.2, plus b, which means that 2 is equal to 3.2 times 0.526, 1.683 plus b. And if I solve for b, I get 0.317. So those are my two equations there. Y equals, I'll just keep it over here. So y equals 0.526x plus 0.317. So that's part A. I have the equations for both lines. And part B is to find the location of the point where those lines intersect. So I'm going to set those equations equal to each other. And that is going to come from, here's the way this works, or one way to think about it. Y is equal to this expression here, which my cursor is over. Y is also equal to this expression here. Since y is equal to both of those things, those expressions must be equal to each other. So 0.238x plus 1 is equal to 0.526x plus 0.317. So if I subtract, basically I'm going to get all my x terms on the left first. So if I subtract 0.526x from both sides, I get 0.238 minus 0.526. So I get negative 0.288x, which is equal to 0.317 minus 1, negative 0.683. And then if I solve for x, what do I get? 0.288, nope. 0.683 divided by 0.288 gives me 2.372. So x equals 2.372. We're not quite done though. I need to find the y value that goes with that. So we can do that from either one of these equations, but I will use the upper one. It's a little simpler, it looks like. So y is equal to 0.238 times 2.372 plus 1. And final result is 0.238 times 2.372 plus 1. Looks like 1.565. So y equals 1.565. So that's the point where those two lines cross. So this is a little trickier. I'm gonna have to come up with my own equations. So I have a jar that has 58 coins in it, some of which are nickels, some of which are dimes. The total value of the coins in the jar is $4.20. So before we write equations, we should probably think about what the variables should be. And really what the variables are going to be, I like to think about this a couple ways. What do we not know? And what would we like to know? And hopefully those are the same thing. So in this case, I don't know how many dimes there are or how many nickels there are. So I'm going to let those be my variables. So let's define those. You can call them whatever you want. But I do think those have to be the variables if you're going to solve for how many of each you have. So x is going to be the number of nickels in jar, and y is the number of dimes in the jar. So part A is to write an equation about the number of coins in the jar. I don't know how many nickels or dimes there are, but I do know that the total number of nickels and dimes is 58. So if I just add what x and y are together, their sum has to be 58. For all I know right now, there could be 57 nickels in a single dime. That's why we need the second equation. And the second equation is based on the amount of money in the jar. So now it matters not only what kind of coins they are, or sorry, how many coins there are, it matters what kind of coins they are and how much they're worth. So every nickel has a value of 5 cents. So if I take 5 times the number of nickels I have, that'll give me the number of cents I have that come from nickels. I can do something similar for dimes. For every single dime in the jar, I have 10 cents. So if I add those together, 5 times the number of nickels plus 10 times the number of dimes, I get the amount of money in the jar. One thing I want to be careful of is the total here is not 4.20 because I'm working in cents. It needs to be 420. So now what I have an equation. I have 2 equations that represent this situation and 2 unknowns. Part C, find the number of nickels and dimes in the jar. Essentially, I want to solve for x and y based on what I have. A couple ways to go about this. We can do substitution or eliminate. You could do substitution, but I just did that for the last question. So I would like to show you what elimination looks like. So what I'm going to do here is I'm going to take this top equation and multiply all of its values by -5. If you're going to do elimination, that's not the only way to do this, but I believe this will work. So that gives me -5x minus 5y equals whatever -5 times 58 is, -290. What is my second equation? I'm going to leave that as is. So why did I multiply that top equation by -5? Well, it's because now if I add these equations together, the x's, basically my x terms annihilate each other. So -5x plus 5x is 0x. -5y plus 10y is 5y equals 130. So if 5y equals 130, divide that by 5, and I get that y is equal to 26. If y is equal to 26, then what does x have to be equal to? Well, I knew there were 58 total coins in the jar. So if 26 of those are y's, are dimes, then the other 32 have to be nickels. One thing we should do, so we think we have a solution, we should probably verify it. 32 nickels is worth $1.60, and 26 dimes is worth $2.60. If I add those together, I indeed get $4.20. So I feel really good about that solution now. All right, moving on to question 3. Two students, Andre and Bethany, are selling donuts and cupcakes for a fundraiser. Andre sold, so we have some data about how many things each one sold, or how many things each student sold and how much money they got. But I want to know, what's the cost of one donut and one cupcake? So again, the first thing we should figure out is what the variables are. So I think in this case, the variables are X is going to be the cost of a cupcake, and Y is going to be the cost of a donut. Both of these things are going to be in dollars. So I have two unknowns. I need two equations. So where are my equations going to come from? My equations are going to come from, basically, I have two students and they sold stuff. So what did Andre sell? So Andre sold 3 donuts. So he got 3 of whatever Y is. I don't know what Y is. I don't know what the price of a single cupcake is, or a single donut. He also sold 14 X's. That gives me what? That gives me $178. So that's one equation. What about what Bethany did? So Bethany sold how many Y's? I know it's weird that I wrote Y first, but it's okay. Let's just be consistent. Bethany sold how many Y's? 14. So 14Y plus what? 6X. So 6 cupcakes. That's equal to 178 as well. So for question 1, I showed you an example of substitution. Question 2, I showed you elimination. Let's do this. Now that we have the equations, let me show you how Desmos might handle this. So if we go to Desmos, turn on the graphing calculator. Let's do these side by side so I can see my equations. I'm going to just put these equations right in Desmos. So 3y plus 14x equals 178, and 14y plus 6x equals 178. So our solution should be where these things cross. So let's see where they cross. And Desmos is usually really good about finding those crossing points. So what were we told here? Draw. We were given this: x equals 11 and y equals 8. So does that make sense for us? Let's make sure. It might seem kind of fast that we got that answer so easily, but let's make sure here. Now, what do we say x stood for? we said that X stood for the cost of a single cupcake. So X is $11 per cupcake. Feels expensive. And probably should have written that down before yeah, $8. So $8 per donut. Let's just check with one of our students here. Does this make sense? You sold 3 donuts at $8 a piece, plus 14 donuts at $11 a piece. Sorry, did I get that backwards? Sold 3 donuts at $8 a piece, plus 14 cupcakes at $11 a piece. That comes out to 24, plus 14 times 11 is 154. That's $178. So if you need to, you can check check Bethany's data and make sure it also matches, but I feel pretty confident that it will. So yeah, hopefully that makes sense. Shows you a few different ways to solve things like this. And that's the end of this assignment.